In this video, we're going to learn about data classification and collection, which refers to sampling techniques. The first, data classification, very important, fundamental in the study of statistics. Much like you would classify the difference between warm-blooded and cold-blooded creatures, and that would be a difference in their behavior, but also in the way that you would treat them as well. In the same way, we have different variables. My little example here is hair color and height. And not only do they look differently, right? Hair color, you might have these different responses, brunette, blonde, so on. Height, you have different responses, maybe 72 inches, 56 inches, all these different heights that we might be measuring. But these variables are treated differently. Let me get into the classification. Now, there's three big categories, really just two if you want to focus on these ones. I'll show you how they break down into three. The first one is qualitative. These ones are the most friendly, the easiest ones to deal with because these are categorical in nature. Category, qualitative, things like maybe hair color, favorite foods, eye color, something where we're putting it into a box and we're saying, hey, look, you fit into this category, second category, and so on and so forth. Qualitative. The second one, I'll put two over here for quantitative variables. These are things which are numerical in nature. Maybe something like height, 56 inches, 72 inches, and so on. Age is another great one. Weight, there's some other examples here. These are often numerical in nature, and they're quite different. I'll tell you, qualitative data, much more friendly, easy to work with, these nice categories to pick, very friendly. But quantitative data is really where a lot of the work, especially as far as statistics, is getting it into. I'll take one, for instance, we talk about average often in statistics, right? The mean, hey, where is most of your data located? Hair color does not make any sense for average versus a height. Yeah, you can find an average for a height. And so it's to that end, the reason why we like this classification is because it helps us decide whether or not variables are going to be interesting enough to pursue. And that's why oftentimes qualitative data are fine, especially for presenting, but quantitative data is the end all to be all when we start comparing and generating descriptive statistics. Let me get into a classification example. Here we go. Classify each of the following, I need to print myself down here. Classify the following data as either qualitative, that's categorical, or quantitative, that's numerical. Indicate your answer by simply circling the correct classification. Let's start off. Different blood types are AB positive, O negative, B positive. So these are those different responses that you may get. These are very much a category. To that end, category, hey, no problem. These things are going to be then qualitative data types. Next one. The amount of red primary dye necessary to make 1 gallon of each shade of red paint. That might be 7 droplets. We might have something like 9, depending on how dark our shade, maybe just one little drop of red. But these are the different types of responses. Those things are numerical in nature. And so we'll talk about quantitative data. And so this is just the fundamental breakdown. Again, one that is fine to present, but not much analytics can go into, at least the way these are phrased. Versus quantitative, much more interesting and diverse. So let's get into a further breakdown that we can see here. So all of these quantitative, these much more interesting variables can be further broken down. This is where we'll get into 3 categories. So qualitative, yes. But then inside of quantitative, we have 2 additional variables to speak of. Inside of quantitative, we'll have the continuous type and the discrete type. All right, 2 again for quantitative continuous and 3 for discrete variables. So for continuous, these are things which are usually measured. Another way we can think about these is measurements which have no gaps between them. All right, something like height is a classic example. Height of a tree, for instance, most classic because these are things which are measured or calculated. Discrete are often things which are usually counted. For instance, the number of tickets sold, pet zone. We can't own half of a pet or somehow get incrementally close to owning 1 pet. And so, okay, pet owners, there's a number that we can count. Those are going to be discrete. Here's a little distinction example between these differences between continuous and discrete. Classify the following data as either continuous or discrete. Indicate your answer by circling the correct classification. Here we go. We got temperatures in Fahrenheit of cities in South Carolina. Temperatures, again, the big question is to ask yourself, is that something that you would count or measure. For temperatures, those are things which are measured, and so that gets us right into continuous. Next up, we have numbers of elliptical machines in every YMCA in your state. Number, again, big question to ask, is it something that's counted or measured? Well, we can't somehow have half of an elliptical, or we're not going to measure up with some kind of yardstick or thermometer for temperature. Number, that's going to get us into discrete. So this is our further breakdown. Again, there's two big categories. There's, back up one here, there's qualitative and continuous. It's the big breakdown. But then we can further break those down, the quantitative ones, into continuous, discrete. So really, again, 3 categories in total. Good. Here's a kind of end-all to be-all example over the classification of data. So we have all these different types we can pick among these 3, and we'll go through and work these examples out. Let's try them. The number of pairs of shoes you own. Again, number. The big breakdown, I'll write this under one of them, and then we'll continue to use it. Whenever you hear qualitative, you should be thinking, hey, I know what that is. That's a category. Quantitative, again, we're thinking that's a number, but continuous tells us that it's a number that's usually measured. Quantitative, again, number, but discrete tells us that it's counted. And so these are the 3 categories: qualitative, quantitative continuous, and quantitative discrete. So when we talk about the number of shoes you own, well, it's going to be a number, but it's certainly going to be something that will count. And so it's going to be 3 quantitative discrete. Next up down over here, we have the type of car you drive. Type, that's pretty categorical in nature, so I'll put qualitative. Next up, I have the distance it is from your home to the nearest grocery store. Variable. The variable we're talking about here is distance. That's something measured, usually in miles, but if you're very close, you might measure it in feet. Get a yardstick out, measure those out. Last one here, I have the number of classes you take per school year. Again, number, something that's counted. We're thinking quantitative, discrete. So again, big deal, because oftentimes we're interested in gathering data or using it. If it's something like qualitative, then it limits our scope of what we can study. So that's why it's important to understand the difference in these classifications. Yes, classification is important. Again, there's 3 of those different types of classifications. On a separate note, we oftentimes want to pair 2 variables together and say, hey, look, these 2 things are related. If we're going to show some kind of relationship, we need to know which one happened first and which one happened second. To that end, we have these 2 different types of variables. Again, different than our earlier classification. The first one's called a response variable. This is one that is usually dependent on what you're giving out. In most studies, this is what you're most interested in studying. This is like the goal of your study, what you're usually going to collect. What you're usually going to collect, the response variable. Oftentimes, I like to think of response variable as the one that you get. The second variable that I'm going to talk about, really the first in our little study diagram, is the explanatory variable. This variable, explanatory, should explain the response, and that's why it's the one that you give. You give the explanatory variable, and then you get the response in return. It's like a chicken and egg situation. Which one came first? Explanatory variable one comes first, and the response variable comes second. And hopefully one helps predict the other is the ultimate goal that we'll get into. Here's our little example. Example 1, your FICO credit score is used to determine your credit worthiness. It is used to determine whether you qualify for a mortgage or credit card, and is even used to determine insurance rates. Effects we'll talk about here in a minute. FICO scores have a range of 300 to 850, with a higher score indicating a better credit history. The given data represents the interest rate in percent a bank would offer on a 36-month auto loan for various FICO scores. Which variable do you believe is the explanatory variable? Again, that's the one you give. And which one is the response variable? That's the one that you get. And again, it really depends on the perspective of the bank, but when you're looking at this credit score and interest rate business, what we should be thinking of is which one are we going to get and which one are we going to receive? And even from a bank standpoint or from a customer standpoint, we have these 2 credit scores, or these mini credit scores and these interest rates. It's like I have this pairing together, ordered pair, we'll use that term later, but 595, and then I get as a response that 18% interest rate. And so to that end, explanatory, what explains the other, credit score should explain the interest rate. And that's the idea, the chicken and the egg, which one came first. For this example, credit score helps explain the interest rate. And ultimately, the interest rate is what we're interested in pursuing. Good. So how do we collect this data, right? If we're trying to establish a relationship, or if we're just looking at the early three classifications that we talked about earlier. Well, there's two different studies or two different ways of gathering data that we're particularly interested in. Two different ways to gather data. The first one is the easiest, cheapest, most common way to gather data, and that's through an observational study, right? This is really just going up to people and either asking questions, or maybe we're just going out and we're measuring worms, or we're saying, hey, look, how long are you, Mr. Worm? And we're picking up this data, again, observational. A lot of times, this comes from large tables where I might be interested just in how long worms are. So I go up there and I measure the length of the worm, but I'm like, hey, you know what, let me gather some other data. So I measure the girth, I measure, maybe I measure their weight, maybe I measure their color, temperature. I gather as much data as I can. And if I put this into a table, not only can I do my little study about how long they are, but then I can also sell off that data that other people may be interested in. Observational studies, very inexpensive and very prevalent. Cheap and readily available. One big problem, though, and this is really the big differentiator, is there's no real connection that you can make for causation, right? When we're just observing data, it's hard to say that I can determine their length. I can discover a causation relationship between their length and their girth. I mean, certainly they might be correlated. There might be a relationship there, but it's really hard to determine causation when you have observational study. And that's where designed experiment comes in. This is where we're designing and we're influencing a situation. So again, big pro, and this is the real differentiator. Designed experiments are going to determine causality because you're in control of that explanatory variable. You are actually going to give that explanatory variable and see how it affects the response variable. But again, one of the most difficult things is it's very expensive to do because you're going to have, if you're either doing a test on worms, because it's a very nice conversation, then you're inputting something in and then getting something in a response. And so you have to either gather these worms, you have to house them, you have to figure all this stuff out. It's much more complicated and therefore more expensive, but bright side, causality is all over the place. Let me give you guys an example here. Which type of study would you conduct? An observational or an experimental design? Circle your answer below, briefly justify your response. Let's get into it. You want to determine the average age of college students across the nation. So average age is what we're interested in getting as a response. And again, the big conversation between these two is observational. I'm just trying to gather data, but experimental design is when I'm trying to show causality. Right? If you're trying to show some kind of relationship or causality, that's going to be experimental design. In this one, I'm just trying to gather data. I just need an observational study. And so maybe I can talk to admissions at a bunch of different schools and just say, hey, can you give me as many names as possible? But I can just make that observation there. Average age, just something I can get. Next one. You want to determine the effect of sugar on a person's mood. Effect. Okay, there's some kind of causality at play. In fact, there's two different variables. I have sugar is one variable, all right, variable one, and then I have a person's mood. That's variable 2. So if I'm trying to show some kind of causality, I have two variables. That's going to require an experimental design. So again, we have these big classifications. It's important to know, look, not only do we need to know what type of variables we have, we need to determine what type of study will get us those designs. But throughout these observational studies or experimental designs, one of the important aspects are I need to understand how to get these groups together. That's exactly what we'll talk about here. When getting these groups, there's often bias all over the place. Bias is just that there's favoring some kind of outcome in our study. For instance, for the sugar one, maybe I'm biased. I think sugar is evil, maybe it terribly is going to affect your mood. Well, that kind of bias can influence my study significantly. Maybe when I'm giving people sugar, I'm making nasty faces going like, okay, here, take the sugar. Oh, it's gross. And then that can affect the study. So we got to be very careful of these types of biases. and how it can affect different designs. One of the big biases that I want to talk about are sampling biases. This is where maybe I talk to a group, but that group is not representative. It is very, very important that when we talk about samples, that we say representative sample. And we'll talk about different samples and which ones are the best, but the nice key thing to think about is, say maybe if I have a population, let's go with a nice number, like 200 people, and let's say we're talking about letter grades here. And let's say if I wanted to break down my 200 people, I had 30 A's, I had 50 B's, I had 100 C's, and I had 20 D's. And so this is my population. Again, for people, it might be easy to gather all this information up. But if I wanted to get a sample, well, hopefully my sample would be representative. But I can't talk to all 200 people. That would be too expensive. And so instead, I want to talk to maybe a smaller group. I only want to talk to, let's pick a decent number so the numbers work out nicely. Let's say 10. I want to talk to just 10 people. Oh, you know what? Let's make our numbers even more friendly. Let's say I want to talk to 20 people. There we go. 20 people. Well, if my proportions are relatively the same, then that's going to be a very nice sample. For instance, 200, if I need to talk to 20 people, let me divide all those numbers by 10. And I talk to 3 A's, 5 B's, 10 C's, and 2 D's. Well, this group, at least as far as the scores are concerned, are going to be very representative of the population. I don't need to talk to 200 people. I can talk to 20 and get the same average score, and I can get a good distribution of what they think. And so that's what we say when we say representative sample, that it should represent that as long as our blockings are relatively similar, then we're golden. This is why oftentimes you'll hear polling where they say a representative sample, or they'll say, hey, look, in voting likely voters, this is what they said, because likely voters should be representative sample. And that's the idea behind it. However, there are different types of sampling, some better than others. Let me show you two main types. Just like before, we have a cheap one and we have the much more rigorous type. Convenient sample is a sample which is just convenient to collect. This is oftentimes what you'll see for the average age of a college student. Maybe I just show up, I stand in a little booth and I ask people nearby. Not a great sampling technique, all right? Not a great sampling technique. It's like I have a population, I'm just going to take these people because they're nearby, and this is my sample. Again, it may be representative, you might get lucky, but not always the case, and so something we need to watch out for. This is the gold standard, in fact, something that you often read as just a throwaway line. A simple random sample. There are a lot of different ways to collect these. One of the classic ones is drawing a name from a hat maybe, or generating some random numbers and pulling ID numbers, but just completely divorced from randomly picking or looking at people. We want to get this as random as possible. So when I see my population and I pull my sample, it should be very tough. I can't just circle and say, yep, there they all are. It should be very tough to do so. And that's kind of the golden standard, simple random sample. So it's important we can differentiate between good sampling techniques like simple random and very not good ones, convenient, which is oftentimes when you read internet polls and things like this, these are oftentimes convenient samples. And so automatically we should be a little bit more suspicious. Let's do an example identifying these different sampling techniques. Identify the types of samplings used in each scenario as convenient. That's not the good one. Simple random, that's the gold standard, or maybe it's neither. Indicate your answer by circling. First one. A student walks down the halls in her dorm, asking students if they would have utilized professional movers, aiding them in moving their dorm rooms for the start of the semester. She conducts this study to persuade the administration to offer movers to all dorm buildings on campus. Wouldn't that be friendly? All right. So again, she walks down the hall. How was her sample collected? And just, hey, what do you think? What do you think? All right. Well, again, that can be very biased depending on her location or even the time, right? If it's like the end of the week and class is about to start, people might be in a bit more of a rush versus in the beginning. A lot of bias going on there, and certainly a very lazy sampling technique. Convenient sample for sure. Next one. To determine who will win 100,000 shopping spree at the mall, the manager draws name out of a box of entries. Draws a name out. Again, it might not be beautiful and perfectly random. especially if there's no mixing up after the fact they're put in there. But that should be a nice example of simple random sample. Again, the golden standard, that one's great. Hopefully very random and no bias involved there. Part C. For budget purposes, a financial advisor needs to know the average salary for instructors at a school, so he surveys every instructor. It's not a convenient sample because, again, this is about as big of a sample you can get. In fact, if you talk to every instructor, you would get the whole population. You know what? I don't think this is a sample at all. I think this is actually technically a census is the word that we use, but certainly neither of those two samples. Look, if you like the video, I appreciate the time that you put into it. We talked about a lot of data classification to different type of variable relationships they can have with each other. That was the explanatory and the response. And then this last sampling technique. There's a lot that goes into these organizations of data. In fact, that's oftentimes how we organize our thoughts as far as what we can do with data and what inferences we can draw. I appreciate the time you spent. I'll see you in the next one.